Welcome everyone, and thank you for joining this webinar, introducing GeoCloud HPC on Azure. My name is Mattis Stordalen-Flister, and I'm the product manager for this product. I'm very happy to have with me Asbjørn Bjørklund, our chief architect. I hope you are all well despite the circumstances. Hopefully, we will all be back in normal operation soon. This webinar will last around 20 to 30 minutes, and a recording will be sent out within 24 hours of completion. It will be available on our YouTube channel. Please ask questions in the chat, and we will answer them either right after the webinar or via email. This webinar is part of a series where we present digital solutions for our oil and gas customers. As you know, there has been huge changes in our business landscape. We want to discuss Cegal business lines with focus on operation and performance, increased productivity, improving digital collaboration, and securing access to critical applications anywhere on any device. Cegal was founded in 2000 with the main focus on delivering generic IT solution. 10 years later, in 2011, the PE fund Novestor acquired Cegal. The strategy changed from generic IT to become a specialist in oil and gas. In 2014, Cegal did a strategic merger with Blueback Reservoir to further strengthen geoscience expertise and global footprint. Between 2015 and 2019, we have had other strategic mergers with, for instance, UK-based Escape Business Technologies and Avito Consulting. Today, we have 13,500 users, 130 customers, 8 data centers, 420 employees, representing 23 nationalities and over 40 expert geoscientists. In 2019, we had a revenue close to $80 million. Cegal is a global company. We have our headquarters in Stavanger, which is also our center of excellence. Other offices are in Oslo, London, Trondheim, Aberdeen, Houston, Calgary, Dubai, and Kuala Lumpur. We have data centers in Stavanger, Amsterdam, Aberdeen, St. Petersburg, and Moscow. And having this global footprint, we are, for instance, able to support you 24/7 all the time. Cegal has a focus on delivering complete end-to-end solution for the energy market. We have our GeoCloud product line with high-performance desktops and applications that can be accessed anywhere at any time. We also provide and create our own software that's specific for the oil and gas industry through the Blueback portfolio. And added consultancy, we believe we add value to the entire E&P workflow. And this brings us neatly into the presentation of the GeoCloud HPC on Azure product. So from a top-down view, for E&P companies that have large simulation requirements, the GeoCloud HPC on Azure is a managed cloud service that provides instant access to unlimited computing power without having to do any costly upfront investments. So unlike generic products, GeoCloud HPC leverages Cegal's unique domain knowledge and provides a bespoke service for the E&P industry. By using this service, you can easily scale up and down the cluster when you need, and you only pay for what you use. We have created an operational dashboard where you will always have the full overview of what's going on in your cluster. I will show you screenshots of this later. We will always analyze and pay attention to what Microsoft and Azure is putting up of machines and hardware in the marketplace, and we will optimize and choose the best ones for the simulators that you're using. We have also created a cost reporting tool so that you will always be in control of your spend in Azure. We are also able to tag jobs so that they can be associated with the project that you're working on. I will show more of this later as well. You get the latest and greatest hardware, and we will choose hardware that has both CPU and GPU capacity so that we get the max out of the simulators. Right now, we have in production support for Rockflow Dynamics TNAVIGATOR and Schlumberger Eclipse. In testing, we are looking at Schlumberger Intersect, and in discussions with customers, we are looking at a number of simulators that we're going to add to the supported stack of simulators. One of them is the Equinor OPM simulator, the Halliburton Nexus. We are looking at the Echelon from Stone Ridge. From CMG, we have IMEX and GIM, and Schlumberger Olga. And we have some interest also for doing Pre-Stack Pro from Sharp Reflections. And now our chief architect, Asbjørn, he will explain how a typical workflow works.
Thanks, Mathias. Hello, my name is Asbjørn Bjørklund. I will talk a little bit about the design of it. This slide shows an overview of which components is used in the HPC on Azure solution, like the Azure GeoCloud, which is the orchestration tool used to provide hardware resources, like the execute nodes, which perform simulation jobs. We also use the IBM Spectrum LSF for the job scheduling and job queues. We are using different queues based on different hardware. Like, for example, we have the high performance series H16R nodes using the Intel Haswell CPU. And we also have the high performance series HC44 using the Intel Skylake CPU. And we also have one series for the using the AMD CPU EPIC, which has CPUs with 60 cores. These three models are the ones we have been using for this test environment we are in production with now. When it comes to file server, we need support for both SMB and NFS. And we have been using both ANF, Azure NetApp Files, which is a storage as a service solution. And we also have tested with Windows file server with NFS support. In our environment, we have VDIs using the RFD TNAVIGATOR simulator, and TNAVIGATOR submit a job to the LSF server based on which queue you need. LSF then submit the resource request to the Azure GeoCloud based on hardware resources required for the job. And GeoCloud is then starting up hardware resources. And these execute nodes will start simulation job when boot is completed. Execute node perform simulation and update the result to the file server using either SMB or the NFS protocol. When an execute node has been idle for 5 or 10 minutes, they are terminated to prevent unnecessary cost to the project. This is in short how we submit the job or the process workflow of it, how it works, and in short how we perform it. So basically, that's more or less what I have to say about the design at glance for the solution. So back to you, Mattis.
Thank you, Asbjørn. And let me now show you how this looks. Unfortunately, only a screenshot, but if you look at this screenshot, you will see this is just a normal Windows desktop. And the point here is to show that even though everything you see here is in Azure, it looks exactly the same for the end user as it has always done. This is TNAVIGATOR, and if you look very, very closely to the window in the center, you will see a queue name and an option where it says H16 on demand. This is the queue that Asbjørn was referring to in the previous slide, which is in Azure. So when the Reservoir engineer here submits this job to Azure, the machines will spin up automatically. The resources will be allocated. The job will run across all of these machines. And when it's complete, it will be turned off. The results are just written to file as before, but the files you see down on the right side here are also a file system that's up in the cloud in Azure. So you're doing everything in the cloud here, but as I say, for the client, it looks and feels exactly the same. And now I want to show you a bit about what we've built on top to give you better control over what's happening in your cluster. So we have something called the GeoCloud portal. It's a product in Cegal that ties together every product that we make for our customers. And in this example, I'm showing you the dashboard for the high performance compute product. So this is an operational dashboard where you can see on the top part of it, you will see a month by month status on jobs. So you will see how many has run for 1 month, the status of those success, or if it's in queue, have they been killed or exited. You can see the queues that has been made in Azure. The queue name, for instance, the first one, NC12 on demand, has 0 running jobs, but over time it had 69, and the runtime as well, and the machine type that's mapped in Azure. So it's when you use these machines in Azure, you pay for the hour or the minute basically per machine type, and it will be different based on the type of machine. You can see the jobs that are queued down below. You can see the running jobs. You can see who has submitted it, when they did, and how long it's been running for. And you also have a history for the last 100 jobs. So the next part I want to show is how we help having better control of cost spending. So compared to when you have your own machines in the basement on your own premises, then you only pay for the cooling and the hardware cost and power and so on, and it's quite predictable what your spend is. Not so much when you go into the cloud, because here you can scale up to any size of cluster that you want. This of course gives you much shorter time to result, but it can also be expensive. So we want to build something on top that gives you full transparency of what's happening. I can start with the first one, is the total cost per queue. So you can see the bar diagrams on the left there, and it's split up by user. You can see the projects that you can tag a job to. So this is quite a handy feature, because sometimes the bill from Azure will maybe be paid by the IT department, but you want to back bill the project spend to an internal project somewhere else in the organization. And then it's quite nice to be able to group those simulation runs together and back bill it. We have an overview of users and cost per queue. And also I'll come back a bit to it. We have something we've implemented that's alert thresholds, and you can see your spend over time. So say that you have this cluster running and you want to be sure you're not suddenly waking up a morning and you have a massive bill in your inbox. We've added this per day and per hour threshold. So for instance, in this example, you can see that the per day threshold is set to 1,000. So that's 1,000 euros for a day. If it crosses this threshold, and if you look on the right side, you can see that you can alert individual users or you can alert groups. And this is of course a bit dependent that we have integrated the HPC product with your existing users, so we actually know their email addresses and phone numbers. In the service, you will get continuous product development. That basically means that we will always add new features. I'll show you a roadmap later, but we will also always keep the simulators up to date. So for instance, TNAV and Eclipse and so on, we've updated multiple times already, just to keep them to the state of the art. We provide access to competency and resources. So we have built up a pretty good understanding of both the needs of the reservoir engineer and also of the architecture needed in Azure and the machines that are needed to do this kind of work. So we will tune everything to be as optimal both on the file system and on the machines and so on as possible. And we put these resources available so that you can ask questions and so on if you need it. We will of course have continuous operation and maintenance of the solution, and we can provide you with custom reports that you get in your inbox over, for instance, the jobs that's been running, the uptime, SLA, and so on. We have a team that's continuously monitoring this solution, and we are backed by third-party support agreements so that we are always secure and making sure that this is up and running in a safe manner. So I just wanted to show you a bit of the roadmap to finish off. So I want to stress that this is very much customer driven. This is not a final roadmap, it's more of a preview, but it's what we are discussing. So for the first half of 2020, we have finished almost everything that's on that part of the roadmap. We have the Schlumberger Eclipse 2019-3 support. The Intersect is in testing, as mentioned. We have TNAVIGATOR 20.1 support. We've created the cost reporting, the operational dashboard, and cost alerting. And we've added our own logic for on top of what you get from Azure to make really sure that the expensive machines are shut down if they are not working or doing anything. And in the second half of 2020, we're looking at adding support for Pre-Stack Pro. We want to make sure the single sign-on functionality is working for your existing users. And for added security, you can bring your own key for encryption of your assets. In Azure, there is a new machine called the HB version 2 machine. It has a 1.4 times faster simulation capacity, I believe, and we want to add that into the product as well. And depending, of course, on customer, what's actually valuable to the reservoir engineer, we want to do more of queue manipulation in the front end in the GeoCloud portal I just showed you. So for instance, you can pause, resume, and abort jobs directly from the portal or prioritize the job queue. Another feature that's been asked for is if you know the type of machine you're going to run a job on and how many parallel runs you're going to do, then it's not really hard for us to do a cost calculator that can give you an estimate of what this simulation run will actually be. in total. Also, for instance, if you submit a large simulation run that maybe goes for a day or two, it would be nice to get an SMS or an email when that simulation run is finished. And this is something that we can easily add into the GeoCloud portal as well, using the same alert functionality I showed you earlier. And we're also looking on standardizing on Azure NetApp files for storage. So moving even more into the future. So just bear in mind, the more we move forward, the more uncertain this roadmap is. But I just want to show you where our thoughts are. We want to add more simulator support. This will also be driven by customers and demand. This will again put requirements on what job schedulers we support. So for instance, the PBS Pro is a popular one. And we have the Slurm one, that is an open source job scheduler. So if we add that in and the simulators are integrated with and works with it, then that's a free, in quotes, alternative for the other one, the proprietary ones. If you have a current investment where you have a large cluster on-prem, you might want to have that for a while longer and not go 100% into the cloud. And then the hybrid HPC scenario is something that we want to look closer to see if maybe we can orchestrate the work from the cloud and you can get all the reports and alerting and so on that we've built, but you can use the compute and storage maybe on-prem. So this is also depending on if this has value for our customers, but it's something we're looking into. And moving way into the future for second half of 2021, we have customers all around the world. Sometimes data centers and the compute nodes that are needed are not there, or maybe you can't move the data out of the region. And then we need to look at multi-cloud support, where maybe we use the other cloud providers' compute capabilities and so on. So you have Amazon, you have Alibaba, and Google. And maybe we want to add in that you actually can just submit a job directly from the GeoCloud portal, but this will be intrusive for the Reservoir engineer. So I'm not sure if that is something that is actually wanted, but it's up for discussion. And in the end, if we have multiple clouds, then the cost calculator should be able to compare. So if you know the specifics of a job, we could then show you, for instance, and say that, okay, if you run it in this cloud, you will have a spend that's X. And if you run it in another cloud, you will have a different spend, maybe lower, and then you can choose. So yeah. So yeah, that's it. I want to thank you so much for watching. And if you want some more information on the product or have any feedback, please let us know at the email. It's webinar@cegal.com. And please don't forget to register for more sessions in our webinar. So thank you, Asbjørn, and thank you, Arne, for setting all of this up. And I hope you will all have a good day.